All right, let's dive right in. Have you ever really thought about what happens after a developer hits commit on a new piece of code? It's definitely not magic. It's actually the beginning of this incredible automated journey. In this explainer, we're going to follow a piece of code through its entire life cycle, all the way from just a few lines of text to a live application running in the cloud. So imagine this. A developer writes some amazing new feature, types git commit, and pushes it. What's next? Does an alarm go off somewhere? Does someone get a page? For a lot of people, this whole part of the process is just a big black box. Well, today we are going to pry that box right open. Honestly, the best way to wrap your head around this is to think of it like a high-tech manufacturing plant. The code itself, that's our raw material, and it's about to be placed on a sophisticated assembly line that's going to build it, package it, and ship it out to a digital storefront. So let's use that analogy to walk through the whole thing. Okay, let's get on to the factory floor. First up, phase 1, building the actual product. In the world of DevOps, we call this the continuous integration loop, or just CI. This is where we take those raw materials, the code, and turn them into a finished, packaged good. So this assembly line of ours, it's got 4 main stations. The whole thing kicks off the second the code is committed. From there, it immediately moves to a build and quality control station. After that, we package the code up in a really specific, standardized way. We call that containerizing. And finally, that finished package gets sent off to a warehouse, which for us is a container registry. Now, before we even think about packaging anything, we got to do some serious quality control. The assembly line runs all these automated checks. First, it runs a bunch of tests to make sure the code actually works like it's supposed to. Then, powerful security tools scan the source code itself to find any known vulnerabilities. I mean, you have to make sure your raw materials are perfect before you start building, right? Okay, so the code passed all our checks. It's good to go. Now we can package it up. This package has a special name, a container image. Think of it like a perfectly sealed box that contains not just the product, but also its instruction manual and batteries, literally everything it needs to work. This is so important because it guarantees our application will run the exact same way, whether it's on a developer's laptop or out in the production cloud. Now, this part is absolutely crucial. Every single package that comes off this line gets a unique serial number. This could be the build ID from the pipeline or maybe the specific git commit code. This gives us perfect traceability. We always avoid vague labels like latest because think about it. In a real factory, you'd never just label every box the latest one, would you? Of course not. And that pretty much brings us to the end of phase 1. Our finished, sealed, and uniquely numbered package is shipped off to our secure warehouse. And in the Azure cloud, that warehouse is called the Azure Container Registry, or ACR. Our product is now built, packaged, and ready for shipment. So our product's built and sitting in the warehouse. What's next? Well, we gotta ship it to our customers. This brings us to phase 2, shipping to production. This is the whole logistics and delivery side of our operation, known in DevOps as the continuous delivery, or CD, loop. And just like the factory floor, this whole delivery process is completely automated. As soon as a new package lands on our warehouse, it can automatically trigger delivery. The system then gets the shipping manifest ready with all the right instructions, and finally, it deploys our product out to the storefront where our customers can get to it. So you might be wondering, what exactly is this shipping manifest? Well, in our world, it's a set of configuration files, specifically Kubernetes manifests. Think of them as super detailed shipping instructions. Our automated pipeline takes a template of these instructions and digitally stamps it with the unique tracking number of the new package we just built. It's basically creating a perfect, accurate shipping label every single time. And here's where the magic really happens, the final delivery. The pipeline connects to our storefront, which is the Azure Kubernetes Service, or AKS. The storefront, AKS, gets the new shipping instructions, goes over to the ACR warehouse, and pulls the correct package. Then it does something really cool called a rolling update, where it seamlessly swaps the old product on the shelf with the new one. And the best part, the customers never notice a thing, 0 downtime. It's just there. Okay, so the product is live on the shelves, customers are happy, but our job isn't done yet, not by a long shot. Now we enter phase 3, which is all about live operations. We have to manage the storefront, keep our inventory clean, and make sure everything stays safe and secure. And this brings up a huge question, right? How do you keep the digital shelves from getting messy? How do you prevent things from slowly becoming outdated or insecure? I mean, trying to manage all this by hand is pretty much impossible when you're working at scale. So how do we automate the cleanup? The answer is, you guessed it, automated policies. Let's break this down. Back in our warehouse, the ACR, we can set up retention policies that automatically throw out old, untagged inventory. We also have security scanners that are constantly checking every package for newly discovered threats. Then, over at the storefront, AKS, we use a practice called GitOps. This basically means our code repository is the one source of truth, and it will automatically fix any changes that don't match our blueprint. It keeps the store looking exactly how we designed it. Well, all good things must come to an end, and every product eventually reaches the end of its life. That brings us to our final phase, the sunset. This is all about what we do when it's time to discontinue a product line and shut everything down in a clean, professional way. And I really can't stress this enough. You can't just delete the project folder and call it a day. That's like just abandoning a factory and walking away. It leaves behind huge security risks. You'll get charged for resources that are still running, and you could even get in trouble for not following compliance rules. A proper shutdown process is absolutely non-negotiable. So here's how we do it right. First, we dismantle the storefront by deleting the app's resources from AKS. Of course, we make sure to back up any critical customer data before we do. Then we go to the warehouse. We find that final golden version of our product, we lock it for archival purposes, and then we purge all the other test and development versions. Next up, we have to shut down the assembly line itself. We go into our system, Azure DevOps, and we disable all the pipeline triggers. This is super important because it stops anyone from accidentally starting the factory back up again. We also make sure our build logs are set to be kept for a long time, just in case auditors come asking questions years from now. And for our last trick, we archive the original blueprints, the source code. We lock the repository by setting it to read-only so nobody can make any more changes. We slap a final tag on it, something clear like archived with the date. And for really important stuff, we might even export it all as a zip file and stick it in long-term, deep-freeze storage. Phew! So there you have it, the entire journey, from a single line of code all the way to a fully decommissioned application. To wrap things up, let's go over a quick checklist you can use to kind of see how your own team's processes are doing. So let's do a quick automation health check. Think about your own setup and ask yourself, can you confidently say yes to these? Is your continuous integration reliably building code and pushing it to the warehouse? Does your continuous delivery pipeline successfully get that code to the storefront? Do you have automated maintenance policies running? And do you have a clean, solid process for archiving old projects? These 4 things are really the pillars of a healthy, automated lifecycle. And that's a wrap. We've automated building, testing, shipping, even cleaning up after ourselves. It's a truly incredible system when you think about it. And it leaves us with one last big question to chew on. Now that this entire lifecycle is automated today, what on earth will we be automating tomorrow? Thanks for joining me on this one.